Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining OSPF Link State Advertisements, or LSAs. Take a look at my free 27-page career roadmap for network and telecom professionals. It'll help you make decisions concerning the next steps to level up your career. It's free at my website at the link in the description below. And as always, if you like what you see, subscribe, like, and hit the bell icon. Now, one of the things that confused me most when learning about OSPF has to do with the Link State Advertisements, or LSAs. What the heck are they, and what do they have to do with routes and networks being advertised? Many LSAs don't actually contain network prefixes, so what's the point in exchanging them? Well, in order to understand what LSAs are, it's important to remember that OSPF is a link state routing protocol. That means that OSPF shares not only networks between routers, but more importantly, it shares topology information so that each router can build an internal map of the whole topology of the OSPF area. That internal map is known as the OSPF Link State Database, or LSDB. Now, after information is exchanged between OSPF routers and the topology converges, each router within the OSPF domain must, by definition, have created an identical topology map, or LSDB. If they're not identical, something has gone wrong. The way these LSDBs are populated is with the exchange of link state advertisements, or LSAs. LSAs are the fundamental building blocks used to share routing and topology information between routers within an OSPF area. Unlike EIGRP or RIP, where updates primarily contain network prefixes, each LSA contains information about a router's links, network segments, neighbors, and external routes. Now, what information is actually included in the LSA depends on the type of LSA in question. Now, there are various types of LSA that are used depending upon which devices share them and what their roles are in the context of OSPF. Each LSA type contains different information and is processed differently. There are currently 11 LSA types defined, but of those 11, there are 5 that are considered the core LSA types, which are the most commonly used, while the other 6 are used either rarely or in specialized deployments. Now, someone else might categorize these a little differently. For our purposes, I'd like to focus on the first 5 most commonly used types. Now, the 5 common LSA types are leveraged by both OSPF version 2 and OSPF version 3, but they might be processed somewhat differently by each version of the protocol and may actually have slightly different names. We'll focus more on those differences when we talk about OSPF version 3 in the future. For now, we'll focus on the LSAs in the context of OSPF version 2. Let's take a closer look at these 5 most common LSA types. Now, LSA types can be referred to by their type number or by their name. The 5 most commonly used LSAs with their type numbers as well as their official names are the following. We have a Type 1 LSA, or router LSAs, Type 2 LSAs, or network LSAs, Type 3 LSAs, or summary LSAs, Type 4 LSAs, or ASBR summary LSAs, and Type 5 LSAs, or AS external LSAs. Now, it's important to understand these names and match them up to the type number, because in different contexts, different methods are used to refer to those LSA types. For example, in the RFCs that define OSPF, both type numbers and names are used. However, in the output of Cisco devices, for example, when you look at the Link State Database, you won't see any type numbers. You'll see only names. So knowing these beforehand will help out a lot in your interpretation of OSPF information. Let's take a closer look at each of these LSA types and see what they're used for. Now, Type 1, or router LSAs, are exchanged between OSPF neighbors found within the same area. Now, a Type 1 LSA contains detailed information about a router's directly connected interfaces, neighbors, link metrics, as well as the type of link. Now, we haven't talked about link types yet, but I'll just list them here. The link types are point-to-point connection to another router, a transit network, a stub network, or a virtual link. Now, it's important to note that the stub network here should not be confused with an OSPF stub area. These are two different things. A stub network in this context is an interface that is either a loopback or a non-shared interface. That is, an interface that connects to end devices and not to another router. Now, some additional information about Type 1 LSAs include the following. Now, this info is important to know early on in order to understand OSPF. Type 1 LSAs contain information only about the local router. They don't relay information learned from other OSPF routers. Type 1 LSAs are always exchanged within an OSPF area. They are not transmitted from one area to another. Type 1 LSAs do not directly include IP prefixes for most link types. The network prefixes are inferred from the IP addresses of the interfaces that are shared as link IDs within the Type 1 LSAs. Now, the only exception to this is when an interface is a stub network, as described before. In that case, the IP prefix is included in the Type 1 LSA. Again, this is unrelated to whether the OSPF area is a stub area or not. Next, we have a Type 2 or network LSA. These LSAs are generated by a designated router, or a DR, found within a single multi-access network segment. Type 2 LSAs are generated on a per network segment basis, and that makes sense since there's one DR per network segment. This LSA type contains information about routers connected to that segment, including a list of router IDs of all OSPF routers on the segment that are fully adjacent to the DR, including the DR itself. Type 2 LSAs, like Type 1, only include information that is local to the local network segment. That is, only information about routers found within the domain of the DR. And note that Type 2 LSAs do not include IP prefixes or subnet masks directly. The prefix is inferred from the associated Type 1 LSAs or the DR's IP addresses, or Link State IDs. Next, we have Type 3 or summary LSAs. These LSAs are generated by an ABR, or an area border router. ABRs are routers that have at least one interface in one area and another interface in another. ABRs essentially sit at the border between two areas. Summary LSAs are used to advertise networks from one OSPF area into another. This allows routers in one area to learn about destinations or prefixes in another area without needing the full link state details or the full topology map of that other area as well. All they need is the next hop IP of the ABR. Now, unlike Type 1 and Type 2 LSAs, Type 3 LSAs actually contain network prefixes. One LSA is typically allocated per prefix, and by default, these networks are not summarized. You can, however, configure summarization at the ABR so that multiple networks within one area are summarized when advertised to another area. And indeed, this is best practice in most cases to keep OSPF updates and routing tables small. Summary LSAs, as their names suggest, provide a summary of all the networks that exist within a particular area. Now, a Type 4 LSA, or an ASBR summary LSA, is used to advertise the router ID of the Autonomous System Boundary Router, or the ASBR. An ASBR is an OSPF router that has interfaces connected to a network outside of the OSPF routing domain. For example, this particular router here, R0, is outside of the OSPF routing domain, and it may inform R1 of routes using another routing protocol, such as EIGRP or BGP. R1 learns about these routes and injects them or redistributes them into OSPF. This makes R1, by definition, an ASBR. It acts as the boundary of the whole autonomous system within which OSPF functions. Once R2 receives such a Type 1 LSA from R1, it knows that it was received from an ASBR. So what does it do? It generates a Type 4 LSA and floods it into Area 1. So a Type 4 LSA is generated by an ABR in response to receiving a Type 1 LSA from an ASBR. Now, what does a Type 4 LSA contain? It simply contains the router ID of the ASBR and the next hop to get to it, as well as the cost to reach it. Each ABR generates this information when it sends out a Type 4 LSA. This essentially tells routers in the whole OSPF domain where they can find this particular ASBR. No routes or network prefixes are included within a Type 4 LSA. So how then is this information used? The prefixes that can be reached using this IP address of the ASBR are found within a Type 5 LSA, which we'll talk about now. The Type 5 LSA, or the Autonomous System External LSA, is used to advertise the specific prefixes that are injected or redistributed into the OSPF domain via the ASBR. Here, for example, the 10.10.10.0/24 network on R0 is somehow advertised to R1 and redistributed into OSPF. Where a Type 4 LSA advertises the ASBR router ID and the routing information to reach it, the Type 5 LSA advertises the prefixes that can be reached via that ASBR. Now, someone may ask, why do we need a Type 4 and a Type 5 LSA? Doesn't the Type 5 LSA contain the information about the ASBR? Well, a Type 4 LSA includes routing information such as next hop IP, as well as the metric to reach the ASBR, whereas the Type 5 LSA does not. A Type 5 LSA will only tell you the router ID of the ASBR that originated the route, but it will not tell you how to reach that ASBR. This is done by design. OSPF deliberately separates Type 4 and Type 5 LSAs in this manner because it is cleaner and more flexible in implementation, and it's easier to maintain information and extend the protocol. This idea is further implemented in OSPF version 3, where more such separation takes place between the actual prefixes and how to get to them. I'll mention here, kind of like a sneak peek, that OSPF version 3 introduces LSA Type 9, which is specifically designed to carry the prefixes themselves, separate from topology information found in other LSAs. We'll learn more about that in a future video. Now, one final word I'd like to mention here. We often think about LSAs as messages sent between OSPF routers, but that's not quite accurate. LSAs, or Link State Advertisements, are data structures that describe topology information, such as a router's interfaces, network prefixes, or external routes. LSAs are not the same as link state updates or LSU packets. LSUs are the actual OSPF protocol messages that are exchanged between routers to carry LSAs. In fact, a single LSU can contain multiple LSAs, which allows OSPF to efficiently flood updated topology information throughout the network. For example, take a look at this packet capture of an OSPF LSU. It contains 11 LSAs of various types, and each LSA contains very specific information as described before. I hope you found this video useful, and if you have, please click that thumbs up button. Please check out my website as well and register for my newsletter. You'll find the links in the description below. And don't forget to subscribe to the channel to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this video has been helpful for you, and I'd like to thank you for watching.